Alright, so we're going to be doing 1.5 exploring angles pairs today. So the first one we're going to talk about is vertical angles. Vertical angles, our definition of vertical angles will be two angles whose sides are opposite rays. So in the example below, we can see here that we've got one ray going out this way, we have another ray going out this way, and we have one ray going from here to here, and from one ray from here to here. So two angles whose sides are opposite rays. Okay, so if I look at angle 1 and 2, their sides, this side is opposite that ray, and this side is opposite that ray. So you can see vertical angles are formed by where their sides are both opposite rays of each other. So vertical angles are always going to be congruent. So in this case here, angle 1 and angle 2 are going to be congruent. And then angle 3 and angle 4 are going to be congruent. Okay. Now, on the next page, we're going to talk about linear pairs. So first of all, a linear pair is going to be, has to fit a couple of different criteria. So one is that they have to be adjacent angles. Whose non-common sides are opposite rays. Okay? And a linear pair is always going to add up to 180 degrees. So as an example, here's angle 1, here's angle 2. Angle 1 and angle 2 are adjacent angles, and their non-common side are opposite rays. Here are their non-common sides. That's one, and that's the other. Okay? So these guys right here, this ray going out this way, and this ray going out that way, are opposite rays. Now, again, linear pairs will always add up to 180 degrees. So the measure of angle 1 plus the measure of angle 2 will have to add up to 180 degrees. They're supplementary. Okay? And we'll talk about that more in a second. Complementary angles are going to be two angles whose measures have a sum of 90 degrees. Okay, so in this case here, angle 1 and angle 2, if this ray here is bisecting this angle, this right angle here, and it's cutting it in half, I've got this is going to be 40, angle 1 will be 45 and 2 is 45, so therefore these would be complementary angles. Okay, then each angle is called the complement of each other. Supplementary angles are going to be two angles whose measures have a sum of 180 degrees. Two angles whose measure have a sum of 180 degrees. Okay, so in this case here, angle 3 and angle 4, I can see that this is a straight line. So because this is a straight line here, I know that angle 3 plus angle 4 is going to be supplementary, meaning that they're going to add up to 180 degrees. So each angle is called the supplement of each other. Okay. Now, in this case here, they're adjacent. Like angle 3 plus angle 4 in this case here. Oops. Angle 3 plus angle 4 in this case here is going to add up to 180 degrees. However, they don't always have to be adjacent angles. For example, if I had an angle like this, and I said it was 40 degrees, and then I had another angle like this, and I said it was 140 degrees, these angles here would be supplementary. Okay, the only thing is, as long as the two angles, so the measure of angle A plus the measure of angle B in this case, has to add up to 180 degrees. If it does, then they're supplementary. Okay, so they can be adjacent, or they can just be two separate angles. Okay? And it could be the same thing over here for complementary angles. They could be two separate angles, or they could be adjacent angles like so. So, given this diagram, they're asking several questions here. So are 2 and 3 a linear pair? Let's take a look. So 2 and 3, well, the problem with 2 and 3 is they don't add up to 180 degrees, right? Because 2 and 3 are not on a straight line. Notice how right here, and then it's going out this direction. So this ray goes out here, but this ray kind of veers out to the left. So the opposite sides, okay, or I'm sorry, the non-common side, right here and here, are not opposite rays, so therefore they're not a linear pair. Okay, so this is a no. Has to add up to 180 degrees. This is more than 180 degrees, this angle right here. 3 and 4 are a linear pair. 3 and 4, so they're adjacent. They're non-common side or opposite rays, and it's on a straight line. So therefore 3 and 4, yes, those are a linear pair. 1 and 3 vertical angles, right here and here. So I'm looking, I've got one line here, but the problem here is this other side for angle 1 doesn't keep going. It kind of veers out and then takes a jagged turn right here. So this is a no. It would have to be kind of like one line going this way and another line going right through it like that. That and that would be opposite rays, and that and that would, I'm sorry, that and that would be vertical angles, and then that and that would be a vertical angle. So our 2 and 4 vertical angles. So again, same kind of issue. I've got a line going through here, and then but over here I have a line, a ray, and then it's kind of veering out down. So this one's also a no. Okay. Or 1 and 2 supplementary angles. 1 and 2, okay, they're adjacent and they're on a straight line here. So if they're on a straight line, that means yes, they would add up to 180 degrees. Or 1 and 4 adjacent angles. So they're right next to each other. They share a common vertex and they share a common side right here. Okay, so yes, these are adjacent angles. Adjacent just means right next to each other. Okay. So we want to find the value of x here in this example. So first of all, we know that here's a straight line. Okay. And I know that on a straight line is 180 degrees. So if I know that on a straight line I have two different angles, I know that they're going to be supplementary. So I can set it up that 75 plus 2x minus 5 equals 180 degrees because they're supplementary. So 75 and minus 5 is 70 plus 2x equals 180. Subtract 70 from both sides. And I have 2x equals 110. Divide both sides by 2. And x equals 55. Okay. In practice problem number 3, they want us to find the value of y. So I can see what kind of angles these guys are, okay, because I have two lines that intersect, and both sides of the angles are opposite rays of the other angle. So for example, this and this, if I continued it out, it's a straight line. If I continued it out, it's a straight line. So I know that these guys are vertical angles and they're equal. They're directly across from each other. So anytime we have vertical angles, they're always going to be directly across from each other. They have, and we can check that by making sure that they're opposite rays with the other angles sides. So here, vertical angles are always equal, so 2y plus 10 equals the other vertical angle, y plus 60. I'll subtract y from both sides, and I get y plus 10 equals 60. Subtract 10 from both sides, and y equals 50. Here, they want me to solve for x and y. Okay. So first I'm going to solve for x, because I know that 3x plus 20 and 5x minus 50, this angle here and that angle there are vertical angles. They're directly across from each other, okay, and their sides are opposite rays with the other angle sides. Okay. So for example, 3x plus 20 is going to equal 5x minus 50. They're directly across from each other. So I'm going to subtract 3x from both sides, and I have 20 equals 2x minus 50. I'm going to add 50 to both sides, and I get 70 equals 2x. I'm going to divide both sides by 2, and 35 equals x. Okay? So that's only half the battle, because I still need to find out what y is. Now, if I know that this is, well, x is 35 here, okay? I need to figure out what this whole measure is, though, or this whole measure, either one. Okay? So I can do 3 times 35 plus 20. So 3 times 35 is going to be 105. 105 plus 20, okay, is going to be 115. and 25. Okay. Now, why is that important? Now that I know that this is 125, I know that from here to here, I know it's a straight line. So I know that there's supplementary y in this 125 degrees because it's a straight line, so it has to add up to 180. So I know that 125 plus this little piece here, y, is going to add up equal 180. So I'm going to subtract 125 from both sides, and I get y equals 55. Okay? Kind of a tricky problem. First you're solving for x, then what you're doing is you're throwing x in. Now that I know the measure of this, I can figure out the whole thing here is 180 because they're right next to each other and on a straight line. Not because they're right next to each other, but just because they're on a straight line. And then, because they're on a straight line, I know that they're supplementary. Okay? And these guys also happen to be a linear pair. Okay? Down here it says, given A and B are supplementary, and they're telling you that A is that and B is that, find the measure of each angle. So they're supplementary, so that tells me that I'm going to be adding them together and setting them equal to 180 degrees. So the 12x plus 1 comes from here, the x plus 10 comes from here. So I'm adding angle A and angle B together to get 180. 12x and x makes 13x. Positive 1 and positive 10 makes plus 11 equals 180. We subtract 11 from both sides, and you get 13x equals 169. Divide both sides by 13, and x equals 13. They want to find the measure of each angle, so I'm going to go back here. The measure of angle A equals 12 times 13 plus 1. Okay? So now I have to do 12 times 13, which is 156 plus 1, so 157 for angle A. The measure of angle B is going to be 13 plus 10, which is 23. And sure enough, because they're supplementary, this angle, this number, and this number, when I add them together, should equal 180. And 157 plus 23 is 180. For practice 6, they're saying the complement of 21 is, so I know that complementary angles add up to 90. So if I have one angle that's 21 degrees, and I have another angle, whatever this angle, 21 plus x has to equal 90 degrees. So if I want to solve it like this, then I can just subtract 21 from 90. Okay, and if I do that, I get 69. Down here, I can do the same thing. The supplement of 21, so they're telling me one angle is 21, and I know that this other angle has to add up to 180. So 21 plus x equals 180. So the only difference is what I'm setting them equal to. Here was 90 because it was a complementary, because they're looking for the complement. Here is 180 because they're looking for the supplement. So subtract 21 from both sides, and you would get 159. Okay. And then on the last part, we're going to talk about angle bisectors. So angle bisectors is going to be, an angle bisector is going to be a ray that divides an angle into two equal parts. Well, because we're talking about shape, we're going to use the word congruent, two congruent parts. Rays are congruent with each other. Okay? So in this case here, ray AY is an angle bisector of XAZ. Okay? So that tells me if this is cutting XAZ in half, because it's a bisector, that means this part and this part are going to be both congruent. Now, we can also show that they're congruent because we can use these little tick marks here. So in the figure above, it says angle XAZ is 112. What are XAY and what are angle ZAY? Okay. So if XAZ is 112, 112 degrees, okay, angle XAY is going to be half of that, so that's going to be 56, and ZAY is going to be the other half of that, which is 56, right? And the way I calculated that was I said the whole thing, so the measure of XAY plus the measure of YAZ, or ZAY, same thing, has to equal the measure of the whole thing, XAZ. Okay? So I don't know what that is, but I know that they're the same, so I'm just going to use the same variable, equals the whole thing, 112. X plus x is 2x, equals 112, divide both sides by 2, and so x equals 56. Okay. Down here it says find the measure of XAZ if x measure of XAY is 4x minus 16 and ZAY is 2x plus 6. Okay? So they want the whole thing. If they're telling me that XAY over here is 4x minus 16 and ZAY is 2x plus 6. Well, I know that they're both congruent because AY is bisecting it. So I can set this here equal to that there. 4x minus 16 equals 2x plus 6. Subtract 2x from both sides, and I would get 2x minus 16 equals 6. Add 16 to both sides. 2x equals 22. So x equals 11. Then if I want to find the measure of XAZ, I can plug it into either one of these and multiply by 2. Or I can plug it into both of them and just add those two numbers together. So 4 times 11 minus 16, that's going to be 44 minus 16. Okay, so that would be 44 minus 16 would be 28. Okay, so this is for the measure of XAY. Oops, XAY. And then for the measure of ZAY, same idea, 2 times 11 plus 6, which is 28. 2 times 11 is 22. 22 plus 6 is 28. Whoops. Okay. So then if I want the full thing, I'm just going to add those two numbers together. 28 plus 28 is 56, which is equal to the measure of the whole thing, XAZ. Okay. So that's 1.5, and that covers most of what we do in Unit 1, and next time we'll pick up with 1.7.